morning, everyone. Hope you're fine. Just 1 second. I have to organize my screen here. So now I'm ready, hopefully. Again, welcome to my talk about building GraphQL APIs with Java. I will give you a short introduction into GraphQL itself. So what is GraphQL actually? What can we do with it? And then we will see several frameworks for Java that allows us to build our own applications with GraphQL APIs. In case you have questions during the talk, please feel free to add them to the chat. I will try to answer them during the talk or otherwise at the end of the talk. In any case, at the end of the talk, we will have a short Q&A session. So you can either ask your questions directly during my talk using the chat or after my talk in the Q&A session. So I hope you have fun with my talk. Building GraphQL APIs with Java. My name is Nils. I'm a freelance developer from Hamburg, and I'm working with GraphQL for some years now. So let's get started. The first part of my talk is about GraphQL Basics. So what is GraphQL? What can we do with it? In which case it might make sense to use GraphQL and so on. And in the second case, in the second part, we will see how you can use GraphQL in your own applications. So this is part of the official definition of GraphQL, and there it says GraphQL is a query language for APIs and a runtime for fulfilling those queries with your existing data. And the talk is more or less about these two parts. The first thing is we will see what is actually the query language, what is actually GraphQL, what can we do with it. And the second thing, this runtime for fulfilling those queries, that is your backend, that is your own application. We will then see in the second part how you will build these runtimes with your existing data or for your existing data. So if you're using GraphQL, you don't have to remove your backend, you just add something to your backend to make it GraphQL aware. GraphQL itself was published in 2015 by Facebook. It's a Facebook technology. But since 2018, the GraphQL specification is developed as an open source project in the so-called GraphQL Foundation, which I think is a subset of the Linux Foundation. I don't know, but it's a GraphQL Foundation. There are multiple small and bigger companies, and this foundation writes the specification and creates new versions of the specification and so on. So it's not a Facebook project anymore. Of course, Facebook is still part of it, but it's not the only player. Also, other big players that are using GraphQL is, for example, Microsoft, Atlassian, Twitter, GitHub, and all other big names. In this specification, or the GraphQL Foundation creates the GraphQL specification, and inside the specification, there it says how the query language looks like, how the query language works, how we define the schema of our API, so how we have to define how our API will look like and so on. But what's not included is implementation. So GraphQL is not a product that you can download from some website and install it and run it. It's just more or less a specification of a language. And there's a reference implementation that is written in JavaScript. But beside that, there's nothing that you can download and just install. So that's the specification. And for almost all programming languages, there are frameworks that allow you to build GraphQL applications using your primary programming languages. So for JavaScript, for Java, C#, Kotlin, and a lot of other Scala. So I think if you don't use Java and you will use GraphQL, you will find a framework for that. Just go to graphql.org and find a list of all supported programming languages. So to show you what GraphQL can do for you, I built a little application. The domain of this application is maybe a little bit early today at 9 o'clock because it's all about beers. This is the Beer Advisor application, and I will show you this application. We don't care about the front end today, but we care about the back end. But anyway, to get an idea what we're talking about in this talk, I will show you this application just in a minute. This is the beer advisor, and the idea of the beer advisor is that you can rate your favorite beers, you can comment on beers, and so on, like any other social media platform, I think. It's more or less common domain, I think, beside the fact that it's about beers, but I think you will get the idea. We have three views in this application, and this is relevant for GraphQL. In this first view here, we see our beers, and we see their names, and we see their average rating and an image of them. And if I now open a beer, we see more informations about this beer. We see, again, its name, its price. We see where we can buy it. We see the comments for this beer that other customers have made. And we can log in and we can rate the beer. More on that later. And the important point is that we, I go back to the first page, that we have a domain model here. This is about beers and ratings and shops. And on each page that we're open, we see different parts of this domain model. Here we see some parts of the beer. Here we see more parts of the beer, but also we see informations about shops where we can buy this beer. We see this comments, we see users. So on each page, we have different parts, different sections of our domain model that we work with. And when I go to the shop, for example, we see more details on the shop now than on the page before. Again, the shop has a list of beers, so we can go back to our beers. The navigation is not that important part. The important part is that we have several pages, and on each page we have different sections of our domain page, of our domain model available. So let's go back. So, and this data, everything of this data is selected from the backend using GraphQL. I will show you that in a minute. But what so the data is read, is displayed here. So we make some GraphQL queries, display the data. But with GraphQL, we not only can select data from the backend, but we can also write data to the backend. And I will show you this. If I log in now, very secure log in here, just my name, then we are doing a GraphQL mutation. This is called mutation GraphQL. We write data to the server. In this case, it's the login request. But another request in this case might be that I give another rating. Too early today for beer. And now I can leave this rating. And again, this is a mutation. And this mutation means that we write data to the server. So we read data from the server using queries. We write data to the server using mutation. And there's a third thing, and this is called subscription. I try to show you. I have to open another browser here, localhost. So I have another browser here open, and that might not be on my machine. That might be another customer somewhere else. And he or she sees the same beer. And I make another rating here. Let's say 5. Very good today. And if I save this rating now, you will see that it immediately appears on this second browser screen here, hopefully. You see, very good today. That was my rating that I just submitted. So, and this is the third possibility of GraphQL. You can get informations about events that on server-side occur. So a client can listen to events on a server that is called subscriptions in GraphQL. And this browser, or this both browser windows, doesn't communicate among each other, but via the backend. This browser listens to events on the backend, and if this browser sends a mutation, data on the backend is modified, the backend sends an information to all the clients that are interested in this event, and then the browser can update its display or do whatever it wants. So this is just the front end. And as I already mentioned, we're using for this client application, we're using GraphQL in the backend, and everything that when I select data here, or if I change data, there are GraphQL requests executed. I can show you just a little proof that I don't lie to you. I reload this page, and you will find here, for example, a GraphQL request. Let's go to the request page. You see something weird here. We will come to this in a minute, but this is a GraphQL query that says select some data from our backend, and then the backend responses with such a JSON request with the data that we requested from the server. So, and As you already saw here, we have such a query notation here where we can select it, where we can select the data from our backend, and I will come back to this query notation now. I will show you some more details about that. If you have a GraphQL application, you have a schema. Every GraphQL API has a schema, and the schema is also queryable using GraphQL. So you can do a GraphQL request against your API to ask, how does this API looks like reflection API in Java. And using this reflection API, you can build tools, or there are tools that allows you to work with your API in a general manner. So there are GraphQL IDEs that allows you to run queries from the browser, for example, just to try your API, like an SQL tool maybe for your database. And this tool is also here included in my example application. It's port 9000. I can log in. And then you see this graphical. This is a prominent GraphQL IDE. You can use this in your own applications for free if you want to. If you don't want to, you don't use it. And the first thing that we saw is that we use a query to read data. It's like this query. I just want a little bit larger here. And in GraphQL, we request data from objects, from object graphs. We request fields from object graphs. And we start the query using the query keyword. And then we can select fields from our API. I can also, in this IDE, I can also get code completion and things like that you know are known from your IDE. Let's say we want to read all beers, and from our beer objects, go away. We want maybe the ID and the name. You see also we have here documentation. The IDE knows your API, your documentation, the type of the objects, and so on and so on. So we run this query, and you see we get a result here, fortunately, and the result looks exactly the same or almost the same as the query. We have the query here, we have the data node here on top, and then we have the fields that we requested. We have the beers here on top level, and each beer now contains the ID and the name. And we can do this as complex as we want, or as complex as our API allows us to. For example, we could also query, in my API here, we could also query the shops with their names and their address and their street maybe. And important is that I can query here things that my API provides. It's not the whole database. It's not anything that I can query, but the things that I allowed to be queried. I wrote an API, I defined an API, and only these things that I defined in my API are queryable and in exactly the same structure that I defined it in my API. So this is not as flexible as SQL for database, where I can do joins and things on all tables. That is not possible in GraphQL. In GraphQL, we explicitly say, this is my data structure, and this can be queried and nothing else. So this queries, the mutation look the same. I have an example here. This is a stupid example. You just wrote a mutation, and then you use the mutation name, and then you add some parameters. I will come back to this later. And also the mutation returns something, and from this return value, you pick the values that you're interested in. And the subscription look the same. You have the subscription keyword, they have a name on the subscription, and each subscription provides an event, and from the event you pick the fields that you are interested in your concrete use case. So this is GraphQL query language in 2 minutes or maybe 3. Let's go back to the slides. Okay, there's a question, would this be faster than querying specific columns in SQL? I think that's not, you can't really compare this, because we will see that GraphQL doesn't say anything about where your data is stored. So that might come from a database, it might come from somewhere else, from microservice, for example. And so you can't really compare this. I think you can build fast GraphQL applications as you can build slow SQL applications, and the other way around. So it's not one-to-one comparable. Okay, this example application, you can find it if you want to have a look on my GitHub account here. GraphQL we have already seen. So the idea of GraphQL is for each use case that I have, be it a client, be it UI client, be it another client, you can exactly query the data that you need for that use case. So I read someone said with GraphQL, you're querying for data, while with REST, you're querying endpoints. I don't know if it's fair comparison, but someone said this. So let's have a look, a more detailed look about the GraphQL query language. The query language we have already seen in the IDE, but again, you query fields, that is in GraphQL called fields, from objects, from object graphs. And fields can also have arguments. You can, for example, I want to have the beer with the beer ID 1. Also, the arguments are defined in my API. It's not everything is possible, but only that I specify in my API. It's just like if you would write a Java interface where you have a method beer with this parameter here, with this argument here. But it's still called a field, and this is an object, and objects have objects and have other fields. And the result of the query is always the same structure that you wrote your query. You see, we have already seen this with the beer here, and then we have the individual fields that we requested. So if a client receives an answer, a response from your backend, you know how the answer will look like if it was successful. So you have this query. We have already seen the query. Operations, these are operations. We have query operation, mutation operation, subscription operations. An operation can have a name that is mostly for debugging things. It's optional. We have the mutation. The mutation looks exactly like the query. We can have a name, and we can have can input variables so that you can. This is like a prepared statement in SQL, somehow comparable. You can write your input object that you want to send with this mutation, and then you can reference this here. So this is an argument for this @rating mutation, and the value for this argument you're specifying using variables, or you can use it. You don't have to, but important is that you send this input to the backend. Subscription is also the same. It's always the same syntax. You have your operation type, you have an optional name, and then you have in this case, the subscription name that you want to execute. You can rename things when you don't like the name of the subscription or the mutation or any other field. You can write with this colon here. You can use another name so that in your response now we wouldn't receive on new rating as the result, but the field new rating. So you can just make the things more comfortable to you. And in this, the subscription I already mentioned is some event that on a server occur. Also, again, I define how my subscriptions look like, how the API for my subscription look like. It's not a general concept that anything in the server is propagated using subscriptions or using events. I have to define my own events. And from these events, the client then can pick the ones that they are interested in. GraphQL server, second part. So the first part that we saw was mostly about the query language. Now the interesting thing, I think, for you is how can I use this in my application? And the GraphQL server is the runtime to execute your queries. And I think a very important part is this second sentence here, or the last part of the sentence, with your existing data. So GraphQL is not a database or something like that. GraphQL is like REST, an API to your existing application, to your existing data and so on. So if you're using GraphQL, you don't have to remove your database or your application or something like that. It doesn't replace anything. It builds an API on top of your application and on your data. There's sometimes a little bit misconfusion in the internet about that. GraphQL itself doesn't say anything about where your data comes from. You might read your data from a database, from a NoSQL database, from a microservice. You can calculate your data when they are requested. GraphQL doesn't say anything about that. Here's a question in the chat about this, about the subscriptions. Subscriptions, or someone already answered. Subscription already or typically are implemented using WebSocket. That's true. Yeah, the question was so that we have to use WebSockets to have live reload as inbuilt functionality with GraphQL. You have to GraphQL itself doesn't say anything how you implement subscriptions, but typically that's true. They are built using WebSockets, and it's not always so easy. I think WebSockets a little bit tricky sometimes. But in the example application, we're using WebSockets. So back to our talk, GraphQL doesn't say anything about where the data comes from. You can, yeah, it doesn't say anything. It's just an API, like with REST maybe, where REST also doesn't care about where your data comes from. And when we're building GraphQL applications for Java, we have two general options where we build this. The first one is GraphQL Java and related projects. GraphQL Java is the base framework for a lot of other frameworks. This is by far the oldest one in the Java world. I think this was released back in 2015 or 16, very short after the first GraphQL release. And since then, several other projects have built on top of it, and we will come back to that later. But GraphQL Java itself is very low level. It's very low level API set, has no server connections and so on. If you want to use it with a server, you have to add some other projects here. The second general option is the micro profile. It's quite new. I think it was released, the first release of the micro profile GraphQL API was back in 2020, so last year. And so I think these are two general options. You're using microprofile, then you use microprofile GraphQL. Probably if you don't use microprofile, you will use GraphQL Java with one of the projects on top here. And we first focus on GraphQL Java because I think it's the most widespread framework. It's the most wide used framework. GraphQL Java itself is only the GraphQL implementation, no environment, like no servers, no JE, no Spring, and so on. And the API is quite low level, but we will see after that there are some frameworks on top of it that build higher level APIs. But I think it's important to understand the basic technology. So I will show you the low level API first. More questions. Is GraphQL a replacement for standard REST API, or should we have such a REST API and put GraphQL on top of it? That is another possibility for using the API. I think GraphQL and REST can be used in parallel. There's no problem if you would provide a GraphQL or REST API. For example, GitHub is doing that. GitHub has a GraphQL and a REST API. The question is if you need that, but it's no problem to have them both. Or some parts, maybe you implement some parts of your application using a REST API and some parts using the GraphQL API. For example, when I'm doing, when I have like a private GraphQL API where only registered customers, for example, can work with, like you have to log in into your application and then you can work with the backend. Then I would probably build the login process using REST and the rest of your application using GraphQL, for example. So it's no problem to use them in parallel. Does GraphQL require additional resources, CPU, RAM? It depends. Yeah, it depends. I mean, is it a separate instance or baked into, say, Spring app? Also, that depends on the framework you choose. The GraphQL Spring framework, which is quite new, which I will show you in 2 minutes. It's baked into Spring, so you don't have to run an own process. And also GraphQL Java, you can just include it in your, if you have a server process, you can just use it inside. It exposes an HTTP endpoint, or you have to expose an HTTP endpoint where the requests come in, and then GraphQL Java handles that and delegates that to your implementation that we will see now. So when we're using GraphQL Java to define our GraphQL API or our application, we have to first define the schema of our API, and then we have to implement data fetchers. And these data fetchers are responsible for getting the data from their data source, from our databases, from our microservices. This is, I think, the hardest part, or the actual part, building a GraphQL API. And when we define our schema, this is important, that you define an API. The API might not look like a REST API or a Java API, but it looks like a GraphQL API in this object structure and the object hierarchies. But you can choose yourself how this will look like, which fields are you exposing, in which form you're exposing them. what are you allowed, what are you allowing to read, what data are you allowing to read from the client, what mutations you will provide, and so on and so on. There are sometimes there are some sentences in the internet that you can read everything with GraphQL, or you can do anything with GraphQL. And this is, in general, it's true, because like with REST, you can do anything with it, but you can restrict also anything. This is very important in my opinion. You can build real APIs with GraphQL. There's another question. The GraphQL API calls, can they only be used by front-end apps or also in calls between microservices? In general, you can use GraphQL to talk between microservices, but I think it's not recommended. I think this is behind this talk, unfortunately. This would take a little bit more time to answer, but the short answer is it's not recommended to do this between microservices. I think the one people that built the first version of GraphQL, of founded GraphQL, said this in a tweet that it's not recommended to use this between microservices. So our GraphQL API have to be defined with a schema. That means you have to write a schema. It's not optional. You have to write it. There are several ways to do this, and the standard way is use the schema definition language, which is also specified in the GraphQL specification. There are other ways you can use programming languages for that, but I will show you how to do this with your schema definition language. The schema definition language is a very simple language, text-based language, where you define the types of your API and which fields your API or a type has, including a type. So an object type has fields, and each field again has a type, like an ID, string, integer. You can specify whether it's optional or it's a mandatory field, and so on. You can have references to other types, and you can have lists and so on. We already saw fields can have arguments. Also, these arguments needs to be specified in your schema, and so on and so on. And important is that you can have 3 entry points into your API. They are so-called root types. It's the query, the mutation, and the subscription. And while mutation and subscription are optional, the query type is mandatory. So if you're building a GraphQL API, you have to use at least one query. And they are defined exactly like your domain types, like your object types. They are called types, and they have specific name: query, mutation, subscription, and everything else is the same like with your object types. They have fields, and the fields again have types. And if you're building now or if you want to run a GraphQL query now, you have your query always starts with one of these 3 objects. So you could query beer, and from the beer, then the beer fields, and so on and so on. But you can't, for example, if this would be your whole application, then you couldn't write a query that starts with shops, for example, because it's not defined. You can only start in this entry points. So this is, you define your schema with this schema definition language, and then you have to implement these data fetcher functions. And the data fetcher functions are responsible for reading the data that is requested for a field. So you get a request for a field beer, for example, and then it's your part as developer to provide that data for the GraphQL framework, so that the GraphQL framework can take this data and send it back to the client. And the data fetcher is a function Java interface. So it means we have exactly one function. It's called get in this case. And with that, we have to build our GraphQL API. I will show you some simple examples. Let's say we have this schema definition, beer. It has one argument and returns a beer, hopefully. This would be an example query. And the data fetcher could look like this. We implement this data fetcher interface. There's this one function method defined called get. We have this data fetching environment parameter that we can use to receive informations about our query. And among others, we can receive the arguments that are provided in this query. So we can say env.getArgument ID. And then having this ID, we can do whatever we want to read this information that we want to send back to the client. This is somehow comparable, I think, to a REST controller endpoint. It's not exactly the same, but you can maybe you get the idea then better. So it's a little bit comparable. If you would have an API/beer/ID endpoint, then this would be the counterpart in GraphQL. If you want to write a mutation using GraphQL Java, it's exactly the same. You again use the data fetcher interface. There's no difference between query, subscription, and mutation. You always implement a data fetcher. You could also do weird things and mutate data in queries, for example. No one would stop you, but of course you shouldn't. The data fetcher for mutations again looks the same as the one for the queries. You have the get method. Using the data fetching environment, you can read the input parameters that you received, like for example, which beer ID, how many stars in this rating example here. And then you call your domain services or your domain repositories or whatever, your domain logic to execute the actual mutation. For example, in this case, I have a rating service that inserts the new rating into the database, makes some consistency checks and so on, and then returns the new rating back to the client so that the client can work with that. Subscription also looks the same. You implement data fetcher interface. The tricky part on this is first you have to expose this using WebSockets, and the second thing is you have to return a reactive streams publish object, which is, I think, a little bit. I'm not that reactive streams expert. I find it a little bit strange to use this programming model, but if you want to build subscriptions and you know how to use this publisher and reactive streams API, then it's really, really easy. And all other things are looking the same. Like now we have seen how to build data fetcher for the root types, the query, mutation, subscriptions, but of course you can also write data fetchers for fields that are not on root types, but on your own types. For example, if you have a Java class where some fields missing that are described in your GraphQL API. For example, in this case, we can query the shops from some beer, but our domain class beer doesn't have a shops attribute because in this example, shops is in a different microservice or wherever. It's not inside the beer. So we have to write data fetcher for the shops query field here on the GraphQL beer type. And we can do this just by writing, again, a data fetcher. And using this environment here, we can get the parent object. In this case would be the beer. So the beer would be fetched using the data fetcher for the beers field that we saw before on the first slide. And then the fetched beer object instance is given to this next data fetcher, to this one. And this data fetcher can then access the beer that is just read from the database or from wherever, and then can execute its domain logic to get the shops for the beer and can return that to the GraphQL framework. And the GraphQL framework makes sure that the client then gets the response for this query in this shape, in this structure. This is data. This is GraphQL Java in 5 minutes. Of course, there are a lot of more things, but this is the most low-level API, I think, for GraphQL in Java. But we have some more high-level frameworks that build on top of GraphQL Java. And probably if you would build a GraphQL API, you would use some of the more top-level frameworks. We have this GraphQL Java Tools framework, which was released first in 2017. We have Netflix domain graph service from February 2021, so quite new. And we have Spring GraphQL, which is even newer, from July 2021. And these projects are based on Spring Boot. GraphQL Java Servlet and GraphQL Java Tools work with the Servlet API from JE. So if you have a JE server, probably this is your stack: GraphQL Java Servlet, GraphQL Java Tools, GraphQL Java. If you're using Spring, probably you would use now one of these two. Let's see how they work. First, GraphQL Java Tools. Instead of writing a data fetcher, you're implementing resolver interfaces. And the resolver interfaces, they work with POJOs instead of this data fetching environment. So you write a GraphQL query resolver, for example, and on your implementation, you have a field, a method that is called exactly the same as the field in your query type in your GraphQL API. And you get the parameters as function arguments. I think this is a way that is very common to us when we're also working with REST controllers, for example, where we also get the query parameters and things directly injected into our methods. Mutation resolver the same. you're writing a function that is called as your mutation, and then you also get the rating, the input parameters as Java objects, and you don't have to use the environment to pull things from a generic hash table. It makes things easier. Same for resolvers that are not for fields on your root types, but on your object types. Here again, the shop examples on the beer field. You just write a GraphQL resolver. This is a generic type. You pass in the parent type, and then you can add a field for this GraphQL beer type by just implementing new methods here. And this is then the parent object. You just get the parent objects. No need for using the data fetching environment. One of the newest framework in this area is Spring GraphQL, which is not available in a stable version, but only in a beta version from July. So it's just a few weeks ago that it was released. This is tied to Spring Boot, of course. You just use the Spring Boot start, and then you can get started. It uses Spring Web MVC or Spring Web Flux for the HTTP endpoints, and it also supports subscription using WebSockets. It's quite easy to set up. And the idea is that we're using controller classes like we would do with REST, but with different annotations. We can, for example, specify query mapping for fields that are for your query type, again, the beer example. And then you write more or less normal Spring Beans. You can have a mutation mapping. And again, the field names here must match the field names in your schema. If they mismatch, then you receive an error or something does not work. You receive the arguments also as Java pojos, as you would, I think it's the same with REST APIs, where you have the payload, or where you can receive the payload using Java pojos. That's different mutations, annotations. And you can also, again, write your own fields that are not defined on your Java classes, but that are defined in your GraphQL API by just using the schema mapping annotation. And then you get the parent objects, and then you can implement your domain logic. So I think this is, if you're using Spring REST API, Spring REST controllers, this is very similar to Spring REST controllers. We also have the Netflix domain graph service, which was released in at the beginning of 2021. It's very similar to the Spring GraphQL project, and I don't know how they will differ in the future, or if they will work together. I have no idea. In the Netflix domain graph service, there are some features that are not available in Spring GraphQL. We have code generators. You can generate code from your API for your Java types. Subscriptions is also supported in GraphQL, Spring GraphQL. And Netflix also supports Apollo Federation. Apollo is another GraphQL service or server and client also. And they have a feature that is called federations, where you can merge several APIs together. It's a proprietary feature from Apollo. Yeah, again, I don't know how DGS and Spring GraphQL will evolve in the future, if they work together or not, and what will be the better framework. I have no idea yet. We will see. The programming model of this Netflix is very similar to that in Spring GraphQL, so I have not an example here. Complete different approach is microprofile GraphQL. A microprofile also uses annotations a lot, but it has another concept. It uses a code first concept. That means you don't define your schema using the SDL upfront and then implement the schema, but you define your schema using annotations in your code base. It's a little bit like when you're using JPA and you annotate your JPA classes, and then from your JPA annotations you let the database build your database schema. So this is a different approach. I have two short examples. You write your types as Java classes using this microprofile GraphQL annotations. So this should be a type. This should be called beer. You can write your descriptions here for the API. You can ignore fields, of course, if you have a Java class and there are some fields that are not visible in the API, you can ignore it. You can specify that they are not null. Everything that you can do with the schema definition language, you can also do with these annotations here. So you don't write a schema file, but you just use these annotations. And if you want to write a controller or something that handles your queries, you use the add GraphQL API annotation and add query, add mutation, add subscription annotations. And then the mapping between the methods and your schema is either done by naming conventions here, or you can explicitly specify the names of your fields, that this method should be the name, I don't know, something different in your GraphQL API. So I think the programming models from GraphQL Java tools, Spring GraphQL, Netflix, and Microprofile are quite similar, and are quite similar to the way we are writing Java EE or Spring applications in general, using a lot of annotations, using dependency injection and such things. Fundamental different is Microprofile uses this code first approach, and the other use the SDL first approach. And the others are mostly tied to Spring, while Microprofile is tied to Microprofile. Fokus, for example, supports this GraphQL endpoint.
Sorry, Nils, for interrupting. Your camera froze.
Oh, yeah. I try to restart it. Uh-oh. Okay, I try another one. Okay.
Yeah, looks good.
The webcam still works, fortunately. Hopefully this is not a bad sign, so that the camera freezes while we're talking about GraphQL. I think we were on this page. So we have seen 4 or 5 frameworks now, and now the question is, what should you use? I think if you're using Spring Boot, plain Spring, the best way would be to go with Spring GraphQL or Netflix DJS. I think they are the simplest one, and I think Spring GraphQL will be in a stable release very soon. That won't take any longer, not very much longer at least. If you're using Java EE, you have to use GraphQL or GraphQL Java tools, and then GraphQL Java Servlet to expose your GraphQL API using the Java Servlet API, because GraphQL Java and GraphQL Java tools both have no web endpoints. They're just GraphQL, but no endpoints. And of course, if you're using Microprofile, you probably would use the Microprofile GraphQL API. I think the Microprofile GraphQL API does not support subscriptions at the moment. I'm not really sure, but I think they don't support it now. Okay, that's for all. I think we have some minutes left for questions, if you have any. So thank you for listening. I hope you gain some knowledge, and if you want to read the slides, you can find them here in this link. If you have any question, please afterwards, please contact me using my email or follow me on Twitter or wherever. And if you have now questions, you can either ask per chat or via audio. And here's the first one. How would you document your GraphQL API? Is Swagger possible? I don't know if it's possible to use this with Swagger, but when you're using the schema definition language, you can write documentation directly in the schema definition language, like you would do it with JavaDoc. You write a comment with such a hash sign, and then you write your documentation. And the documentation can also be queried using the GraphQL API. So if you have exposed your API, you also expose the schema, and tools can request the schema and can request the documentation for that. So that you have, even in the IDE, in your real IDE where you're doing your Java programming or JavaScript programming, you can have the type informations and your documentations directly in your code. I think in my example here, that currently doesn't work, unfortunately, because I misconfigured something, where we can just check your page. I think you see, hopefully you can see it. This is now a TypeScript example, but the same would be true for every other programming language. I wrote my GraphQL query here inside my IDE, in my TypeScript file in this case, and the IDE knows this is a beer, and it also knows the documentation, and it also gives me here directly in IntelliJ IDEA. I have also code completion for the fields with the documentation and so on. And the documentation itself is a short example. Is written directly here in the schema definition file using this one. You can also use, I think you can also use Markdown, so you can format this a little bit. And then this is part of your API and can be requested by tools. More questions. I think we have 2 minutes or 3 left. Check if there are more questions. Not the case. It's quite early to talk about so much about beers. I hope you enjoyed the talk anyway. Could you show the Java interface again, please? Which one? For the data fetcher or from one of the other frameworks? The data fetcher, yes. Hopefully I find it. Query. Query now. In this repository, you find some examples for the different frameworks. Fetchers, beer advisor data fetcher. Here we go. And for example, this data fetchers are using the lambda notation here. But anyway, this is how a data fetcher would look like. You have this data fetching environment parameter, and you implement your business logic to receive the data. And there is another part that I haven't showed you that connects this data fetcher function to a field in your schema. I skipped that part because with this higher level frameworks, you don't have to do this because it's done automatically. If you're using GraphQL Java, the most low level API, then there's another part in this application that says this data fetcher should be invoked if the beer field on the update beer name mutation is executed on the mutation type, for example. We have here another one, the shop fetcher, that is where you can read a single shop, or we can also, here maybe this is a very simple one. This is the beers fetcher where you just receive all beers. It just calls my repository and returns them all. It's probably not a good idea to do this in a real application, but I think you get the idea how these things work. And somewhere else in my application, I said this function should be invoked if query beers is executed. Hopefully this helped you. Any more questions? Okay, I think we're also at the end of the time. So if there are no questions anymore, again, beer in the morning was hard, but a good example. Yeah, I think so. This is the last slide. I can also write the link to the slides in the chat. So this is the PDF, and inside you find also the link to the repository with the example application. So again, thank you. I wish you a nice day and a lot of fun at the rest of the conference. And maybe, yeah, I wish you a lot of fun with GraphQL if you want to try it. Thank you very much. See you.